So this video is for lesson 22.2 and 22.3, and this is all about trigonometric ratios. Okay, so in case you're wondering what this means, so metric means to measure, and trig means triangles. So it's the measurement of triangles. Okay, more specific, it has to be a right triangle. Okay, so for these lessons, you are going to need your calculator. It has to be a scientific because you need these functions: sine, cosine, and tangent. I will show you how to use them in the video, and if you still have questions, just come see me at lunch. So we're going to be using three of them, and the first one is going to be sine. Okay, and sine is defined as the sine of any angle. So that is, I'm not sorry, not any angle, that has to be an acute angle. Okay, and that is equal to the opposite over the hypotenuse. Okay, the next one is cosine. Okay, and then we use cosine of an acute angle in a right triangle, which is equal to adjacent, the adjacent side. Adjacent means next to. Okay, over, so adjacent over the hypotenuse. Okay, and then the last one that we're going to be using in this class is tangent, and we use tan of theta is equal to opposite, the opposite side over the adjacent side. Okay, now we use something that is called SOHCAHTOA to try to memorize this, because if you look at this, so is sine equals the opposite over the hypotenuse, cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. So let me show you how to set them up. Okay, so when I'm doing these problems, I always like to write SOHCAHTOA on top of them, because that way I remember how to set them up. Okay, so it's a little trick so I remember. So let's say you start with a right triangle, right? And then this one is your right angle. Now you have two acute angles. You can pick any. So I'm gonna pick that one. Okay. Now in a right triangle, we know that the side across the right angle is known as the hypotenuse. That side never changes. It's always going to be the hypotenuse. What do I mean by changing? If this angle is up here, these two sides are going to be changing names. This is what I mean. So if the angle right here, it's here, this one, the side across from it, is called the opposite. Okay? And the side that is next to it, this one right here, is called the adjacent. Okay? So now on this one, let's do the same thing, but now the angle is going to be at a different position. So here's my angle now, so you can see the difference. Now across the right angle, we have the hypotenuse, right? And then across this angle, that is our opposite. Okay? This is what I mean by changing. If your angle changes position, that means these two sides have to be relabeled based on where this angle is at. Okay, so if this one is the opposite, so that means this one has to be the adjacent. Okay? So now, that's how we set it up. That's why we got sine. Sine comes from the opposite angle over the hypotenuse. Okay, cosine is the adjacent over the hypotenuse. Okay, and then the tangent is the opposite over the adjacent. Okay, that's what we have these three ratios at. Okay, so let's go ahead and do a few examples so you can see what I'm talking about. And for this, you will need your calculator. Okay, so let's say I have this right triangle. Okay, and I know this is a right angle. Okay, and I know this angle is going to be 25 degrees, and this side is going to be unknown. We don't know that side, and this side is going to be 35 inches. Okay, whatever. So you have to look at this. Now here is your angle, right? So that's a reference angle. That's how it's called. Reference angle. Now, based on this angle, we're going to label our triangle so we can set up the trig ratios. Now, you know that this one does not change, so that one is your hypotenuse. Now, across from 25 degrees, we have the opposite. Now, we don't really need the adjacent because we don't need to find anything, or nothing is given to us on the adjacent. So let's just focus on these two sides and this angle. Now, so this is what SOHCAHTOA comes in handy. Okay, so now you're going to look at this. Okay, so what information is given to you? Did they give you the opposite? Yes. Did they give you the adjacent? No. So that means we cannot use tangent. Now again, they didn't give you the adjacent, but they gave you the hypotenuse, but you don't have the adjacent, so you cannot use cosine. Now if you look at this, sine is defined as the opposite over the hypotenuse, and that's exactly what we have. So that means we're going to be using sine of my reference angle, which is 25, sine of 25, and we know sine is equal to the opposite, which is x, over the hypotenuse, which is 35. Okay, and now from here it just becomes a proportion, because you know that that's pretty much over 1, and this is where you have to use your calculator to figure out what this value is. Okay, so if you're using sine, you just look for sine, and then you press on it, and then you're going to enter 25 here. Okay, you're going to get a decimal value, which is 0.4226. So 0.4226. Be careful on how you round, please. So then all we have to do is cross multiply, right? So 1 times x, you get x. And then we have to multiply 35 times 0.4226. Okay, the reason we're able to do that is because similar triangles and ratios. So then we just multiply 4, so we do 35 times 0.4226, and we get an answer for x, which is 14.791. You can round it to 14.8, and there is your answer for x. Okay, and that's it. Now, if you want to find this side, which I'll probably will ask you later, you can use the Pythagorean theorem now, because now you have two sides in the right triangle. But that's later on. Today is just an introduction. All right, let's look at a different example. Okay. Excuse me. So let's say I have this right triangle. Let's say I have this one is going to be let's make that one x again. This is my reference angle right here. We're going to make it 47 degrees. And this one is going to be 16. Okay? So now here's a reference angle. A reference angle is 47. Okay, I know this one is the hypotenuse, but I'm not going to label it because I don't have any information for it. Okay? But I have this one, which is across my reference angle. So this one is known as the opposite. Okay? And then this one must be the adjacent. Okay? So now you're going to look at this and be like, well, let me write SOHCAHTOA Okay, and then you're gonna go through every single one until you get that. So let's look at this. So this one works, this sine works with the opposite and the hypotenuse. We have the opposite, but not the hypotenuse, so we cannot use that one. What about cosine? Cosine works with the adjacent and the hypotenuse, but we don't have the hypotenuse, so we cannot use that one either. So now we're left with tangent. So tangent works with the opposite and the adjacent, so we're good to go. So let's go ahead and set it up. So we're going to do tangent of my angle, which is 47 degrees, and that is equal to the opposite, which is x, over your adjacent, which is 16. So again, I'm using tangent, again, tangent of your angle, 47, and that is equal to the opposite over the adjacent. Okay, so that's the setup. So now we have to use our calculator again. So now we're not using sine, we're not using cosine, but we're using tangent, and we're using tangent of 47 degrees. So then that gives you 1.0724, because we're rounding up, and then we're going to put over 1 so that way we can do cross multiplication. Okay, so then we cross multiply again. We're going to get x equal to 16 times 1.0724. Okay, so now I'm just going to multiply that by 16, and there's my answer. X is equal to 17 point, let's round it up to 17.2. Okay, and we are done. So there's your x, and that's tangent. Okay, let me show you one where you have to use cosine. Okay, so this is example 3, and then cosine works like this. So let's go ahead and draw a different right triangle now. Okay, and let's make this one 65 degrees, and let's make this one 10, and let's make that one x. Okay, so let's label our triangle first. So remember, always label. So that one is across my right angle, so that is going to be named as the hypotenuse. Now here's your reference angle. You don't have anything across, so you don't care about that one for now. But now next to it, you have the adjacent. Okay, so now let's bring out SOHCAHTOA. Okay, now again, we don't have an opposite side, so we cannot use sine or tangent, right? But we have the adjacent and the hypotenuse, so I'm going to use cosine. So it's going to be cosine of my reference angle, 65, is equal to adjacent, which is 10, over my hypotenuse. Okay? So again, the 10 is your adjacent, because that's the definition, and then x is your hypotenuse. Okay? So cosine of 65 is equal to the adjacent over hypotenuse. Cosine of 65 is equal to adjacent over hypotenuse. Okay, so then now we're going to use calculator again, and you have cosine of 65. You press enter. Okay, and then you get 0.4226, and that is equal to 10 over x. Okay, so again, we're going to make it over 1 so we can have a proportion. So we do 1 times 10, that gives you 10, and then we have 0.4226 times x. Okay, so let's divide each side by 0.4226. Okay, so let's do that. 10 divided by 0.4226, you are getting 23.7. So that is the value for your hypotenuse, 23.7. Okay, now so that's pretty much what we are going to be doing in class for those 2 lessons. But now let's just do a quick check. So make sure that when you're finding sine of any angle, so let's do sine of 25 with your calculator, you are in degrees. So you see how you have DRG here on this calculator? you have to be in degrees. Otherwise, you're going to get a different answer. So let's just check really quick. So sine of 25 is 0.422, 0.4226. Okay, so now let's do cosine of 30. So cosine of 30, you are getting 0.8660. So this is just checking, make sure we are on degrees. So calculator must be on degrees. Okay. All right, so let's do sine of 30. We should get 1/2. There you go. So sine of 30 should be 1/2, and that's how you check that you are on degrees. Okay, I always like to use that one because I know it. Sine of 30 is equal to 1/2, and that's how you do it. Now, if you have a different type of calculator, let's say you have this one, okay? To change degrees, you click on mode. Well, first turn it on. You click mode, and you see how you have degrees right there, and then radians. You always want to be in degrees, so you press on it, you click enter, and then you just quit. And then again, we can check. Now on this calculator, you need to press second, and you see how it says trig right there, right above pi. You have to press that, and there is all your trig functions. So you have sine, cosine, tangent, and we have sine inverse, cosine inverse, tangent inverse, but we're going to use those later. So again, let's do sine of 30, just to double check, and there you go, 0.5. Okay. Now, if you have a different type of calculator, this one is already on degree. You see that D right there. So let's just check sine of 30, and that gives you 1/2. So you can get that in decimal just pressing that. Okay, press that, and you can go back to a fraction. Okay, so this is different calculators. Just let me know if you need help. Oh, there's one more. This one is a little tricky because you have to go backwards. Okay. So this one is sine, cosine, tangent, right? But if you press sine, nothing happens. So you have to go backwards. So we're going to do sine of 30, but first you press 30 and then sine, and there's your answer. So some calculators you have to input it backwards, which is kind of, it doesn't feel natural. Okay, so if you are not going to be in class, this is what you need to do. Okay. So as part of your classwork, okay, you need to do page 312 through 313, and that is numbers 1 through 4. Okay, and then for homework, you have to do page 311, numbers 11 through 14, and page 314, numbers 5 through 9. Okay, again, if you have questions, just come see me at lunch, and thank you very much.